Good morning, Tahmina Khan is here in TKMaths is 1. This is video number 3 in continuation of the topic function. In the earlier two top videos, we have seen these explanation. In video 1, we understood these terms, and in video 1, and in video number 2, we look at the explanation of domain and range of the linear quadratic function, and how to sketch those graphs, and how sketch help us to find out the domain and range. So this video is about composite function, and like I said earlier, the first 4 videos are same for O-level ag maths students and for AS level mathematics. Then from video 5 it will be different. I have explained to you in video 1 which topics are not part of AS, which are of O-level ag maths, and which of AS topics are not in O-level ag maths. So from video 5 onward, they will be different videos. Okay, so let's start the composite function. So composite function is what? In a very, very simple language, if we try to understand, we can say a composite function is generally a function that is written inside another function. And we will see it in 3 examples here. So composition of a function is done by substituting one function into another function. So let's see what does it mean. So here are 2 functions, f of x and g of x, and they both are defined for the real values. X belongs to real value, x belongs to real value. Now in this example, we have to find out g of f of x. Now I have shown here 3 solutions. This has been seen through observation and experience that students express this in these 3 different ways. So let's see one by one. So now if you look at the working of this student A, what he is understanding by g of f of x? Can you see what this student is taking g of f of x as? He is taking it as a multiplication of 2 functions. So he is multiplying function g and function f here, and this is what he got. Now look at this. I'm not telling you which one is right and which one is wrong at the end, but let's see first of all what 3 students are thinking. Now if you look at the student B, what he's thinking that function g is going inside function f. So what he's doing, this 3x minus 1, he's substituting in place of x here, and that's why he's getting 2 times 3x minus 1 minus 5. So he is putting function g inside function f, and this is what we have seen in the definition. Then one function goes inside another function, right? And look at this third student, what he is doing. So he is replacing this x here by this function. So what he's doing, he is substituting, let me change the color, he is substituting f inside g, right? So if you look at student B and C, they're doing the same thing, but student B is substituting function g inside f, and student C function f inside g. So which one is right? Student C is right. The meaning of this notation is that function f will go inside g. So this is the meaning of the question. So now we will continue with examples. I hope you understood this here. And error and correction I have all explained you here. So this is what we have seen, that composite function g of f can only be formed when the range of f is within the domain of g. Now this is something very, very important, and this is where confusion arises. Okay, what does it mean? Now, by the way, in this video, which is on composite function, I'm taking very simple examples. In video 5, which is part of AS level maths only, I will go into the detail of this. I will take the examples particularly where this concept will get more, or will be better understood. But right now I will try to explain a bit here with the help of easy example. When he's saying, okay, if you are writing g of f then whatever is the range of this will come should be in the domain of this. This is what the meaning of the question is, right? So we'll see this into detail. Now let's see this example, because right now we are focusing on simple composite function. So two functions are given to you. You have to find f of g of x. So we have just seen the notation f of g of x mean this function g will go inside function f. So in 3x plus 2, in place of x, you will write 7 minus x. Okay, so you can see here what he has written here in the solution. Instead of g of x, you can write first step the function itself. Remember when you do in maths f of 2, what does it mean? That in function f, wherever you have x, you will replace it by 2. When you write it like this, it means wherever you have x in function f, you will replace it by 7 minus x. So here, in place of x, we are replacing it by 7 minus x. And we got the function f of g of x. What is the meaning of f of x? This can also be written as f square x, which means function f is going inside itself, right? Oops, sorry. Okay, so to make this work simple, f of x, you can write f, and what you will write here? 3x plus 2. So this thing, 3x plus 2, will go here. So it will become f of 3x plus 2, f of 3x plus 2, and you will plug in here, substitute it here. So this is what you're getting. So this is a simple thing which is often asked in O-level maths and very rarely in AS level also. But you need to understand this concept for the advanced level concept. Now example 2. Now here if you see x greater than minus 2. Achha, by the way, one thing I forgot. Okay, no, this was only function. Until I get the value, I cannot explain you the meaning of it. So I will get those values, I believe, here. Let's see. Function f is given to you, and it is given for the domain x greater than minus 2. Similarly, function g is given to you, and it is given for the domain x greater than 2. You have to find f of g of 7. Now there are two ways to do it. One is simple way, other is little complicated, depending on the functions you have. So I have solved here by both ways. So let's see case number 1. Now what is happening in this case? F of g of 7. So first of all, we are finding out what is g of 7. So when we substitute g of 7 in this function, here you see, you got 4. It means instead of g of 7, you can write 4 here. And this is what I'm saying. Is this value 4? Because 4 is the range of this. 4 is the range of this. It is the range of this. Is this value within the domain of f? This is what function is saying here. The range of f should be in the domain of g. So now I'm asking you, once you get g of 7, you got the range of function g. Is this range in the domain of f? Let's check. The domain of f was saying x greater than minus 2. And f comes within this category easily because 4 is greater than minus 2. So the condition satisfied, and we will continue, right? So you solve it and you get 1. It means the answer of this is 1. Okay? This was a simple question. He was not asking you if it is not, then what. Those I will cover in my 5th video. I'm just explaining you concept, simple examples here. Now, this was one method. So I said that there are two ways a student attempt it. This was easy and correct way, and it helps to handle the complicated cases. When I will cover it in the past paper questions, then you will get an exposure of it. So let's see the second method. Students usually do here in the second case, Sorry, this one though I wrote. Let me erase it. Okay, so usually what happened, the meaning taken out of it is that first of all find out f of g of x, this function. After finding out this function, plug in 7 in it. Method is right, but it is tedious and long method. So let's see here. So if you're finding out f of g of x first, the function g of x was this. So it is written here in place of g of x. In place of g of x, we are writing the function. And then this function is acting as a domain for f. So it will go here in place of x here. So you can see here I have written it in red to make it prominent. After that, I will simplify it if I want to, or if I don't, I can plug in the value of 7 because this is my function f of g of x, right? So now I'm substituting the value here, 7. You see I'm replacing x by 7 and I'm simplifying it. I got answer 1. Same answer which you got here, right? So this will be a helpful method in case of complicated questions, but this is also fine. Sometimes you don't get the answer by solving this question. What type of answer? I'll discuss later. So I would recommend that make a habit of using this method, which will save you multiple times. Now last example, x squared plus 4x. This function is given to you. This is function f and function g is given to you here. You have to find the values of k for which this equation has real solutions. Now, it means you need to find function f of g of x now. You have no choice, right? So let's find out the function f of g of x. What does it mean? It means this function g, let me change the color, this function g will go in function f in place of x, right? You can see we have written here in place of x, 4x, x squared. After that, you simplify it, you got 9x squared plus 6x minus 3. And it is saying equals to k. So now this whole thing is equals to k. What comes in your mind? What will you do now? It is saying find the values of k for which this equation has real solution. Now, do you remember? It is related with the quadratic. What is the discriminant has which type of inequality or equation if it is real solution? Greater than equals to 0, right? So now, after rearranging it, now we will find out, or we will apply the concept of b square minus 4ac greater than equals to 0. So my a is 9 here. My b is 6 here. And my c is minus 3 minus k. So now you will apply, just a minute. You will apply b square minus 4ac greater than equals to 0. And the reason is, it is saying the equation has real solution. So this is the discriminant greater than equals to 0 for that case. Plug in the values of a, b, c. Solve this inequality, you get k greater than equals to minus 4. So values of k are greater than equals to minus 4. If you plug in, you will get real solution. So with this, I end this concept of composite function. Video 4 is on inverse function and it's a sketch. This is again the topic of both for O-level Ad Maths and AS level Maths. So thank you very much for watching it. Please share it and subscribe it if you like it with your friends. Thank you. Take care.